In section 10.7, we're looking at equations of circles, so we're actually putting circles in a coordinate plane, or on a graph. Starting with the discovery, I'm putting a circle in the coordinate plane and I put its center at the origin, which you can imagine is probably the nicest place to have the center of the circle, and it is, and it'll come up with the easiest equation here. Because what you can do is, I can pick any point x comma y and a radius r, so I'm going to pick a point that is not a nice one, so how about right there? Well, this point I'll call x comma y. Could be anywhere on the circle, okay? You could put any x comma y, that's why I'm not writing the numbers, it's just general. And radius of the circle is r, so I'm ignoring the fact, I know this radius looks like it's about 8 here, but let's say the radius can be anything, it's just r. I'm going to write an equation that relates to variables, and it's easier than you think. Because you can form a right triangle using the, actually, x-axis in this case, and going up whatever y is. Now, however far you move to the right, like this point, I went to the right whatever x is for this point, and I went up whatever y is for this point. Right? This point you go right x, you go up y. And now I formed a right triangle. Now this right triangle could have been formed anywhere you put that x comma y, and the radius is always the same. Now tell me a wonderful equation that relates the legs and the hypotenuse in a right triangle. Well, Pythagorean theorem. You know that one leg squared plus the other leg squared equals hypotenuse squared. One leg is x squared, however far you went to the right or left, plus y is however you went up or down, squared, that's the other leg, equals the hypotenuse of this triangle is always the radius of the circle, so hypotenuse squared or r squared. Kind of nice. Any point on a circle, you do x squared plus y squared, you get the radius squared if the center is at the origin. So write this down, this is important. Anytime your center is at the origin in a circle, the equation is this simple, and the only thing you need to have a value for is the radius. Okay, so if I told you that you had an equation of a circle that was x squared plus y squared equals 64, you could tell me, I know the radius because this is radius squared, and square root of 64 is 8. That's basically the equation of this circle here, because 8 squared is 64. Also, it wouldn't matter if the x was negative or the y was negative because you're squaring them. So anyway, this is the equation of a circle when the center is at the origin. Nice and simple. X squared plus y squared equals radius squared. So you can write an equation of a circle that's shown very easily, as long as the center is at the origin here, and it is. I need to know the radius. That's the only thing you need to know, because you write x squared plus y squared equals r squared. X and y are generic, anything x and y, so that's why you don't plug anything in for those. Remember, every equation of a line or hyperbola always had the x and y in there. In this case, what's the radius? Well, I would just look the cardinal directions up, down, left, right, and it looks like radius is 4. No matter whether I look to the left, right, up, or down. But keep in mind this is 4 squared here, so 4 squared is 16. There's the equation of the circle that's shown here. Okay, center at the origin, very simple. If you just see x squared plus y squared, the center is at the origin. And just make sure this is radius squared. So I just had to figure out the radius was 4, and do 4 squared, 16. Alright, let's make it more interesting though. What about a circle with the center not at the origin? Okay, and we're going to call the center h comma k. If you notice here, here's my h comma k, and radius is labeled to a random point x comma y in that circle. I'm still going to form that right triangle. But now the legs are a little bit harder to name or to come up with. Think about this. This is our horizontal leg, I guess, of this right triangle. This is how much we're moving left or right. And we know the left or right movement deals with the x variable, right? X moves left and right. And here we have x, here we have h. H was the center x point. Well, if I want to figure out how much I went here to here, if this was over, 5, and this was over 10, the difference from 5 to 10, you'd be like, oh, I moved 5 from 5 to 10. I've subtracted, right? You took 10 minus 5. So in this case, you take whatever the x is here, and you subtract whatever the x was at the center. So x minus h, that's the length of this leg. And then you look, how much did I move up or down for this leg, and up or down is y. And this one is just y, and the y of the center is at k. Well, if you think if this point was up 8 and this point was up 10, from 8 to 10 that's a difference of 2, right? Because you took 10 minus 8. Well, in that case, you're taking whatever y is minus whatever k is the y of your center. And there's that leg. And then do Pythagorean theorem again. One leg is x minus h. That's the left-right leg. But again, it's leg squared. Plus, the other leg is up-down, is y minus k. And again, that's squared, and it's a quantity, so parentheses, squared. Equals, the hypotenuse is the radius. So once again, the radius is squared here. This is the equation, standard equation of a circle. The thing is, the center is at h comma k, which means there's a number going in for h. There's a number going in for k. Okay, h is the x of your center point. Notice it's in the x spot of your center. K is going to be the y value of your center. And finally, you know that the r, of course, is your radius. And keep in mind that radius does have to be squared again. So, standard equation of any circle in a coordinate plane, center can be anywhere. All you have to do is put the x of the center here and do x minus that h, which is the x of your center, squared, because that would be the leg going left and right, plus y minus k, where this is actually the y of your center, so that you're figuring the up-down leg. And that equals the radius squared, because we're looking at that Pythagorean theorem off of the right triangle formed. So make sure you got this down today for standard equation of a circle. And let's practice here. Let's write the standard equation of a circle described. So again, I'm doing x minus h squared, h is the x of your center, plus y minus k squared, k is the y of your center, equals r squared, r is your radius. Oh, also keep in mind, these start as minus signs, right? So actually, if the x of your center was a negative, subtracting a negative would turn this to positive. And since this started as minus as well, if the y of your center is negative, then it would actually turn to positive, right? Because it would be subtracting a negative. So keep that in mind. Be careful with your signs here. We have to deal with that right away, actually. So the center is at negative 2, 3. Now this is the x of your center is negative 2, and that goes here is your x of center. So I'm doing x minus actually a negative 2. And of course, subtracting a negative turns adding the opposite. So in this case, it's actually x plus 2. Okay, so it only turns a plus if it was a negative because you're subtracting a negative. X plus 2 squared. Plus, now I do y minus the y of my center, and the y of my center is at 3 squared. And that equals radius squared. Oh, okay, so the radius was 3.8. So you actually have to do 3.8 squared. I'm going on the calculator here. I don't know that one off the top of my head, but I get 14.44. Okay, so I made sure I did the radius squared. With the center of the x, it was negative, so it was minus, negative turned to plus. And the y of the center was just 3, so it was y minus 3 squared. There is the standard equation of that circle. So you can come up with the equation if you have info if you're given the center and the radius, but you can also come up with the standard equation of a circle if you have a picture. It does require you to identify the two important things, though. You need to know the center of a circle. You need to know the radius of a circle to be able to come up with its equation. Where is the center of the circle? It is marked for us, so I need to write down this point. X comma y, or h comma k, really, for that center. I'm not going left or right. X is 0. And I'm going down 1, 2, 3, 4. So 0, negative 4 is my center. To find my radius, from the center, just count up, down, left, or right, and see what your radius is. Like if I count to the right, it's 1, 2, 3, 4, 5, 6, 7, it looks like. If I count up, 1, 2, 3, 4, 5, 6, 7 as well, and up, left, right would have been the same thing there. Radius is 7 then. Okay, let's come up with the equation then. Use my generic outline. So I'm doing x minus, what is the x of the center? The x of the center was actually 0. So x minus 0 squared plus, and then I do y minus whatever the y of the center was. It was -4. Oh, okay. Minus a -4, so it'd actually be y plus 4, right? Because subtracting a negative would have turned to positive. And that equals radius squared. Radius was 7 squared. Remember, this is all coming from a right triangle formed by any point. Because it would be whatever the x is minus where I started with x, plus this leg would have been y minus wherever the y of the center was. And we'd square both of those because it'd be leg squared plus leg squared equals hypotenuse squared. I wrote it this way, and I'm going to simplify here. Because first of all, I don't need to write x minus 0. X minus 0 is just x squared. Plus, and then I do need parentheses around y plus 4 squared equals, and I'm going to do 7 squared and get 49. And this would be the best way to write the equation of that circle. Okay. Hardest example of today. You're given the point 8, -1 is on a circle with a center at 4, 2. Write the standard equation of the circle. And the first question I have for you is, what do you need? There were 2 things you need to write the equation of a circle. You need the center. Yeah, we have the center. It's 4, 2. But you also need the radius. And if you don't have the radius, but look, I have a point on the circle and I have the center. And I know the radius is the distance from the center to a point on the circle. Distance from center to a point on the circle. Here's my circle symbol. So in this case, I'm going to need distance formula. Remember, distance formula is basically Pythagorean theorem. It looks a lot like a circle equation. You subtract the x's, square them, plus subtract the y, square them. And then we take square root to get, because it would have been d squared, and we undid that by taking square root. So distance in this case is actually radius, right? Because we're finding distance from the center to this random point. So what is the radius of this circle? Big square root. First subtract the x's. 4 and 8 are the x's. To subtract in any order here, I'm going to do 8 minus 4 squared. Plus, and now I subtract the y's and square those. The y's are -1 and 2. -1 minus 2. Remember to subtract and square that. Square root of 8 minus 4 is just 4 squared. Plus -1 minus 2 is -3 squared. 4 squared is 16. Doesn't matter that it's -3 because it's squaring, so negative times negative is positive. 3 times 3 is 9. Well, look at that. 16 plus 9 is 25. The radius is a square root of 25. The radius is 5. 25 is a perfect square. Square root of 25 is 5. Alright, now that I have the radius, I can write the equation of that circle. Remember, the equation of a circle, you do x minus h squared. H is the x of the center. Plus y minus k squared. K is the y of the center. Equals the radius squared. And I have all of this info, so I'm doing x minus the x of the center. Center was at 4, 2, so the x of the center was 4. So x minus 4 squared plus, I do y minus the y of my center. The y of my center was 2 squared equals the radius squared. Radius was 5. I found that out by doing that distance formula. And actually 5 squared would be 25. There's the equation of that circle. So may even need distance formula today. Another thing you should be able to do is if you have the equation of a circle, you got to be able to graph it. So let's put this circle on the graph. Well, what are the 2 things that you should be able to identify about that circle given the equation? The 2 most important things. I should be able to identify the center. I should be able to identify the radius. Here's the thing, you have to be really careful when you're picking out the center. Remember how this starts as a minus for both of these? It only turns to plus if it was a negative number going in. So when I look here and they say that where's the x of the center, I'm looking at this 1. Now it stayed a minus, so it really was just 1. The y of the center went here. I'm looking at the 3, but remember how this started as a minus? The only reason that turned to plus is because the y must have actually been negative 3, and it was subtracting a negative turned positive. So remember, it's almost like the signs are backwards from what you actually see. I'll go back 2 here. Remember how with a negative 2 for x, it actually turned to plus 2? And a positive 3 for the y of the center looked like minus 3? Because it starts as minus for the equation. Just be real careful of that, okay? So this was actually 1. This was actually negative 3 for my center. And then for the radius, if 36, now remember that this is r squared, right? So actually I'm taking the square root of 36 to get the radius. So the radius is actually 6. Now the way I do these is first I plot the center, and then I do points up, down, left, and right, and go from there to draw the circle. So the center's at 1, negative 3. That point 1, negative 3. There's my center. If the radius is 6, I'm going to go up 6, put a point, down 6, go right 6, and left 6. And now you draw a circle through those. I'm going to cheat a little bit here. Grab my circle tool. And when you do these on your homework, just do your best to make that circle go through those points that you just created. Okay? And one more example. Kind of cool here. It says 3 forest ranger stations are at these points, A, B, and C. There's a fire located 2 miles from A, 3 miles from point B, 3.5 miles from point C. Find the location of the fire. Well, if I'm, okay, let's start with point A, I guess. A is at negative 3, 2. Now, if there's a fire 2 miles from A, that's a 2-mile radius from A, right? So that's like a circle around A with radius 2 in a sense. So I'm going to do that where I go up 2, down 2, left 2, and right 2, and draw a circle. That's a really bad circle. Okay, still not great. We'll leave it though. We're 3 miles from B. B was at 2, 2. We're 3 miles from B, so that's a circle radius 3 from B. So again, I'll go up, down, left, and right. Ooh, we're matching up there. And again, I'll try to make a circle with that radius 3 at B. And finally, 3.5 miles from C. C was at negative 1, negative 1.5. 3.5 mile radius from C, basically. 1, 2, 3.5, yep. 1, 2, 3.5. 1, 2, 3.5. 2, 3.5. All right. Not bad. It looks like we've located the fire right here where all of those circles intersected. Look, it was 2 miles from A, 3 miles from B, 3.5 miles from C. It's at negative 1, comma 2. Okay? So talking about circle equations in a coordinate plane today, being able to graph them and write those equations.